JFace architecture in Eclipse. Here you can see a bit more detailed JFace architecture. We will now discuss the various roles and relationships. Here we focus on viewers and their collaborations. The listeners, which implement the application reactions to user input in the sense of controllers. JFace viewers target specific widget types. The core contribution of JFace layer relates to its selection of generic viewers, each of which targets a specific type of widgets. A table viewer targets tables. A combo viewer targets a combo box, and so on. Viewers use the widget specific methods for displaying data and listen for widget specific events. JFace viewers access the application data through adapters. One question not addressed is how JFace will actually access the application specific data. How is a generic viewer supposed to know the right get data method and the implementation of observer pattern of specific data structures? First, each viewer holds a reference to the model in its property input. However, that input is a generic object, so the viewer never accesses the model itself. Instead, the viewer is parameterized by two adapter objects that enable it to inspect the model just as required. The content provider is responsible for traversing the overall data structure and for splitting it up into elements for displaying purposes. For a table or list, it provides a linear sequence of elements for a tree-like display. It also accesses the child and parent-like links between the elements. Furthermore, content provider must observe the model and notify viewer about any changes that it receives. Label provider is called back for each element delivered by the content provider, usually to obtain concrete strings and icons to represent the element on the screen. A list viewer will request one text icon combination per element. A table viewer or tree viewer will request one combination of each column. The viewer will also observe the label provider to be notified about changes of the text and icons to be displayed. The text-related viewers, text viewer and source viewer, deviate from this schema in that they expect an implementation of iDocument as their model. The document itself then includes a text-specific access operation without requiring a separate adapter. The framework includes a deliberate redundancy regarding changes in the model. When values change within a data element, then those may be translated for the viewer either by the content provider by calling the viewer's update method, or by the label provider by firing change events. Each mechanism has its merits. On the one hand, the content provider observes the model anyway, so the label provider can often remain passive. On the other hand, some generic label providers, such as those used in data binding, may wish to avoid relying on a specific content provider. Here you can see widgets interacts with viewer. Set icon and set text are passed from viewer to widgets, and selection is passed from widget to viewer. Viewer interacts with content provider. Get elements are passed from viewer to content provider, and refresh is passed from content provider to viewer. Content provider interacts with model. Get data is passed from content provider to model, and change is passed from model to content provider. Viewer is connected to model, and input is passed from viewer to model. And widget is connected to listeners. Events are passed from widget to listeners. Viewer is connected to listeners. Model level events are passed from viewers to listeners. Viewer is connected to label provider. Get text, get icons are passed from viewer to label provider. Listeners are connected to model, and invoke operations are passed from listeners to model. And now this is the end of my presentation. Thank you very much for watching it.